Okay, so let's get this party started here. All right. Got some debug stuff happening. Okay. So, here's the situation. I got a mysterious email, and I guess I don't know how much they didn't really say whether they were keeping this secret or not. So I don't know how much information to talk about, I guess. But somebody was like, "Hey, I noticed that you were working, on Handmade Hero, and that you were complaining about Visual Studio Debugger. So I went to see how much work it would be to just make a thing on Windows that does all the debugging stuff, and it wasn't that hard." He's like, it took me about a week to get everything working, and he's sent a video that was like, showed running Handmade Hero, setting a breakpoint, and printing out the stack frame, and like walking a struct and finding all the data. So I was like, all right, that's basically it. That's all we need. And he was like, what features do you actually need so we can plug this into 4Coder as soon as Alan gets like custom debug UI stuff working? And I'm like, well, I'll go ahead and walk through all the debugging features, and we can try to prioritize them in terms of which ones are, more important and which ones are less important. But I'll just figured I'd go through them now in a way that's easier to enumerate by just watching this stream rather than having to hunt through all of Handmade Hero to see all the sort of stuff that we do. So I'll start by saying, obviously, there's the basic operations that you use to control the program. And the most important thing to understand here is that you want to be able to run the program reliably and quickly in a number of configurations. Now, Visual Studio is actually bad at this. So whatever you actually do will probably be better than it. So let me say first what it does and then what you could do that's much better. So the way Visual Studio works is it has this Solution Explorer thing, which is awful. And it's not even set up for doing this part of what we're doing. It's meant for like making projects and whatever. And it's bad at that, and it's also bad at this. So what you actually want here, and Qt Creator actually does this much better, is what I want to be able to do is set a number of configurations that I will run as this program, right? So this thing here where I go to properties, how there's like, what the program arguments are and what the working directory is, right? And then what the environment variables are, for example. The things that you set when you launch a task. Like, I don't care about any of this stuff right now. We'll get to some of these later. But in terms of the three important things, it's environment variables, working directory, and arguments. Those are the things that when you create a process in Windows, you can specify. And they are important for debugging because you're oftentimes trying to debug different ways of running the program, such as different directories in which you might run it, different environment variables that might be set, different command line parameters that you might be passing to it. So what has to happen here is I have to go in and manually change these every time if I want to do something else. So if I want to pass like something to Handmade Hero, like minus full screen or something, then if I wanted to change it to windowed, I have to go in here every time and change it back to windowed or whatever, right? And that's just lame. And if you, in Visual Studio, if you want to have more configurations, right, you can't actually do that unless you create a real project. So you can't actually save like sets of those. So a much better solution than what they have would be if you could just create a series of configurations that are what these three settings should be, these three strings, and then so you basically have like a bunch of run ability, right? Here is the way that I want to run this, and in my opinion, the executable name should probably be part of that. Meaning, I may be developing a project that when I build like 3 different executables, and I might want to run like one of them or another one of them, and I might want to switch very quickly between them. So the best possible thing would be just a set of configurations, and the configuration is what's the executable to run, what are the arguments you want to pass to it, what is the environment strings that you want it set to, and that's less important. I would probably never use that, but people who are trying to debug command line utilities might be nice. So that's like a lower priority one. The command line argument's very important, environment not as much, and then what working directory it's in. And you can just set those 4 things any number of times. You can make 20 different configurations or whatever, and then you just set whichever one is active somehow in the UI. So I say right now, for now to the foreseeable future, I am debugging this setting. And so from now on, whenever I say run, I want you to use those settings. And then later on, and I can run as many times as I want, and I want that to always be true. And then later on, if I decide I want to debug a different configuration of my program, I just say I'm switching to this other configuration now, right? And so just to give an example of what that would be like, it's like, let's say that I have a program that's supposed to copy a file from one place to another. It's like I'm implementing the copy command in the shell or something. So I wrote copy.exe, right? But I build 2 different versions of it. I build copy.exe and I build like copyfast.exe, okay? And there's a couple different types of file copies I want to test. So I want to create a bunch of different configurations. I want to do like copy.exe, w:/foo.bat to w:/bar.bat, right? Then I want copyfast.exe with w:/text.txt, whatever, blah, blah, blah. And I want to be able to just save all those up and just pick one of them, run it, and have that be the thing. I don't want it tied to anything else or any products or anything. I just want those configurations. I want to be able to switch to them very quickly. And assuming that this is in 4Coder, then those would be just something that like I can customize in my 4Coder config or whatever. Where if I want to load them out of a file, I could do that myself, or whatever. It doesn't have to be like a whole UI for creating this first. Maybe that's something you want to do down the line for ease of use, but all of that could be done in like the 4Coder config file. So all you would really need is an API where I could set up what the configuration was. And at first, you wouldn't even need like a window to display it or anything. It could just be like, I'll take care of it in my 4Coder config and I'll write whatever UI I need for it. So really all that has to happen is I have to be able to set that when I say I'm going to when I'm going to do a debug, I'm going to launch a debug or whatever. I need to be able to specify those 4 things. So I feel like there's a pretty clear path there. It'd be like the first thing would be in the 4Coder config, you can set those 4 things and then launch, start debugging. Then the next step up would be, something that actually allows you to edit those and save them, or edit those and they're saved automatically. And then a final one would be like, there's, the concept of like a project file of some kind that saves these. So you can load, I'm working on this project now, so I load in its config file, or I load in this other config file, and that comes into 4Coder, right? And I feel like, so there's a pretty nice progression there where you only really need the first one to be really useful, and then later it kind of moves on. So once you've set the configuration, then really the important thing is you can set that configuration, leave it set, and it's remembered, and I can just hit F5, or whatever the key that's bound is, to run the program, and the program runs. And then I want to be able to do Shift F5 to kill it. We don't really need that up right now. So I've got a run key and a kill key, which will always work. I want those to be rock solid, so I can always run the program and always shut it down, right? Very, very simple. So those 2 functions. The next function that you would want is the stepping functions. So I want the ability to be able to do a step in, right? So saying that I want to do like a step, I want that to automatically break at main, right? I want to be able to step into the first line of the program, just like start running my program, okay? And I want to have step over, which is the kind that we normally use, and step into, which goes into a particular function. Now, in my opinion, Visual Studio doesn't do this particularly well. the way that would be the best possible way to do it, although those two I get by with, like that's how I debug every day, is just having one thing that steps over the current line and one thing that steps like into anything that that line calls, right? This two standard ones. A better thing would be to sort of have a little more control over that. And I feel like there's kind of an arbitrary amount of coolness you could do depending on how advanced you wanted to get. So the two important ones to actually get working are just the step over a line. So like run whatever that line is, no matter how much stuff that does, run until you hit the next source line in this file right where I am, right? And then the other one is step into the next source line no matter what it is. So, you know, obviously we all know exactly what these are. If I hit, if I hit step over on Win32 LUTX input, then I'm going to jump over it, right? Whereas if I was actually here and I hit F11 to step into, I actually go to the function. So those are the only two that actually need to happen. But there's an arbitrarily more cool set of things you can do there, and that is that oftentimes on a particular piece of code, especially as the code gets more complicated, there may be multiple things that are going to happen on a single line of code. So, for example, if I jump down to, I don't know if the platform code is not probably the best example of that necessarily, so I may want to go into the game code, but I'll just scan really quickly here. Yeah, I'm gonna actually jump into the game code instead, because I think that's probably a better place to show what I mean in terms of where there's opportunities for more stuff or more interesting game code to occur. So, or sorry, more interesting debug code to occur. So let's take a look here. How about handmade world mode? This may be a little bit better. And yeah, let's look through here. So here's an example. So here's a function called pushRectOutline, and what pushRectOutline does, I don't know if will we ever get here? Yeah, we will if I do this. PushRectOutline, when I get to this line of code, what I might be doing, like mentally when I'm debugging, there may be multiple things that I'm trying to do here. One thing that I might be trying to do is actually step into pushRectOutline because I want to see what pushRectOutline is going to do. The other things I might do is want to step into default flat transform. Another one might be to step into this v3 constructor. Another one might be to step into this v2 constructor, right? So there's 4 functions that get called from this line of code. And they get called, you know, this one gets called, and this one calls, and this one gets called, and this one calls probably, right? I think the compiler is actually free to kind of do those in a different order. But point being, we know that these will get called, and then finally this one will get called. So one of the real pains in the butt is if I just want to step into pushRectOutline and I hit F11, I'm in the middle, I'm off in some constructor for a type that I didn't care about at all. Like, we've called that constructor so many times, I just don't even need to remotely be stepping into that constructor. In fact, that constructor is not even on this line. That was a default constructor that was getting called out here, right, as a default parameter. So I didn't even see that one. That was an additional one that's getting called. So there's just an immense room for coolness here. After you got the basics going, you could go infinitely far on this, I think. Because one simple example would be step into the base function call versus step into all the function calls, right? Because one key would do like, okay, step into that v4, now step into the v2, now step into the, right? Which is what Visual Studio allows you to do. But another thing would be, oh, just step into the outermost function call, because that's probably the one that I want to see most of the time. So having a key that was just look for the outermost function call and step into that would be pretty amazing, right? It's a harder thing to implement probably because you need more information from the debug system to know what that even means. So that's definitely harder. Going further still would be the concept that you could have some sort of a debug expansion, right? Where, okay, so there's let's say I did something like there's 3 different keys that I have, maybe 4, right? So I've got step into and step over, the kinds that we have currently. Then I've got a key which is like do that root one that I said, which is kind of sort of, but an even cooler potentially one might be a step over function call or something, which would be like the first time I hit it, it would just execute this. It would like highlight that and show like, so instead of just thinking that I'm on a line, it would actually be like, it would show that I was right here. It would point at like, or like this or something, right? It would point at the actual thing that I'm doing. And if that thing was a sort of a phantom, it would like just add it somewhere or like hover it over. It would like do some kind of an overlay, right? Then I'd hit it and it would move to here. I'd hit it and it would move to here. I'd hit it and it would move to here. And then I'd hit it and it would move to here, right? So in addition to step over the line, there'd be like step over the function, like the next logical thing that would have taken me to a new place, but instead I want you to just step over that and show me the quick return, right? Because that would be pretty great as well, especially if what I'm trying to do is step into this thing, then instead of having to do something like maybe, you could engineer some more cumbersome thing where I gotta grab the mouse and pick it or whatever, I can just do like bang, 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 and like the little thing goes like doot, 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 and then I'm like step in, right? So that might be really cool as well. Obviously, just like I said, infinite number of cool things here. And while we're talking about infinite number of cool things, you could also imagine doing things that, debuggers could have been doing forever. Again, none of them are any good, so they never do any of these things, but the debugger knows what the return values are from each of these things. You could replace or hover over these things after they get called with their return values. So you can actually see the parameters getting passed to this thing, right? There's nothing to stop the debug info from being displayed in a really nice way there that doesn't involve me doing all this work. So, there's an infinite number of things I think you could explore with respect to step control and displaying what happened with step control that debuggers they don't even think of. They don't do anything interesting with it, right? And you could do so much interesting stuff there, even just basic stuff, because it does take a little bit of implementation, but it's not revolutionary. Like, it's not like, oh my God, like, how would we ever do this? It's like, it's really actually a very straightforward extension of what they already do. It's just nobody's doing it, right? Again, all that stuff is all pie in the sky, like, hey, it would be great to have these things, but really the only two things that matter are step over a line and step into. Because that's what I've been getting by with forever, so obviously it's good enough to get started. And it's the only thing that Microsoft Visual Studio does anyway. Okay, so in addition to those two, while they're sort of a little bit lower priority, but they're still pretty useful fairly often, so they're not like pie in the sky stuff, they're actually fairly things you would want to have relatively soon. Is you also want to be able to do some of these more specific operations in here. So for example, set next statement and run to cursor are pretty handy things to have. And what those are just like, hey, if I want you to run to right here, instead of having to set a breakpoint, run and unset the breakpoint, it's kind of just a nice thing to have to be able to like run to the cursor, right? And similarly, if I want to play with the execution pointer, so I want to hard set it to somewhere else, being able to right click and say set next statement is also kind of nice. That's basically totally breaking the way the program works. It's saying hard set the instruction pointer, the IP, right? This thing. There it is. It's saying set the instruction pointer directly here right now. Don't run to it, don't set breakpoint, don't try to execute the program, just jump it back there. And now I'm going to rerun that code, which may totally break the program, but it's just like when you're debugging, sometimes you want to do that because you want to see what that code's going to do and blah, blah, blah. So it just tends to be a nice thing to have, if that makes sense. Okay, so that's for control for stepping and all that sort of stuff. And that's pretty much it in terms of what you need. Like I said, so it's real basic. Stop the program, start the program, step into the program, and start at WinMain, right? And I like that being bound to just step into. So when I step into something, that's what that does. And then I've got step over and step into working normally as they would, we would expect them to work. And that's all good. And then hopefully eventually too, you'd have run to cursor and set next statement. So then we would get to breakpoints. So breakpoints, again, there's so much stuff you could do with them, but the important things is just the ability to set a breakpoint on a line, right? So anytime I am somewhere, to be able to set a breakpoint on that line. And then also to set a breakpoint at a particular function name. So for example, if I wanted to set it right there, win32 get last write time, to be able to just type that in and hit return, right? Now, normally it doesn't show up until you actually run the program, and that's fine because it doesn't know where it is necessarily, or who knows what. I don't even know why, because it hasn't loaded the symbols yet, probably. I'm not sure. But point being, that's an important feature as well, to be able to set a breakpoint by file, by function name. Those are really the only two that I use. So I could get by with only those, but there's a lot more stuff that you can do with breakpoints, and Visual Studio does have more stuff with breakpoints. We'll talk about those in a second. But the main priority ones would be those two. I can do almost all my debugging with only those two. And so that's really mostly what matters. There's an important usability issue here. Those breakpoints, A, should be listable, obviously, but they should also be remembered. They need to be remembered across runs of the program. Because oftentimes I want to set a breakpoint, run the program, make some changes, run the program again, and I want to break at the same place every time. So it's very important that they don't go away after the program stops running. They need to be like kept persistent so that every time I run the program, any breakpoints that I've set will be active unless I told you to get rid of them, right? So that's, relatively important. Now, as far as like further out, like more talking about more advanced features that can be added for breakpoints. So again, those are the ones to get working first, and then only once everything else, like when I say here's the stuff that's priority 1, that's the stuff you want to implement all first, and only once all that was going, because then you'd have a completely usable debugger that could replace Visual Studio just fine for like people like me. Only then would you move down, I would think, to the tier of like, here's all these nice to have things that are pretty cool, right? So stuff that's pretty cool, some of it Visual Studio does have, right? And so what it can do, for example, is you can add a condition to a breakpoint, and a condition is the ability to type in some simplified C expression, which will evaluate, and only if it's true or if it's changed since the last time through, will the breakpoint be hit. So what this means is, like, if I want to set a breakpoint and I want to say, well, I don't really want you to stop here unless the file name is non-null or something, right? Then what I can do is say, well, this breakpoint that I set, I want to have an additional conditions associated with it. I want to say that file name has to not be equal to 0, right? And then then when it runs through here, it will only trigger the breakpoint when that's true. Now, in this case, that is true, right? Because file name, I believe, is always set, right? So you can see that it actually stopped here. But if, on the other hand, I was to take it and make it be something that was not the case, so I say file name does have to be equal to 0. We don't do that in Handling here, I don't believe. When we run the program now, that breakpoint doesn't get hit. So that's just sort of, if once you have the ability to evaluate watch expressions, it's really just tying those two together. But that's a much more advanced feature in terms of how far you'd have to be down the road to debugging, because it requires you to have expression evaluation already, which is not something you would need to do to just get the thing working in a basic context. So, right, because you can watch variables without expressions by just having just the bare symbol lookup. Once you get the ability to do symbol lookup by expression, now all of a sudden you can tie that into your breakpoints and have that be an interesting extension, right? So that's what that feature is. Now, similarly, you can also do other stuff here where, let me get rid of this nonsense. In fact, let me just delete this. So another thing that I could do, for example, if I come through here, and I have this file name parameter, it's pointing off to something. One thing I might do is want to create a breakpoint that is not about a place in the code, but that is instead about memory. So what that is I could say I want a new data breakpoint, and I could say, well, where actually, well, of course I can't because it's modal, Visual Studio, thank you so much. I might want to say, well, that location file name, here's its address in memory. So I know it's pointing to some block of memory somewhere. So if I grab that and I say, okay, I want you to break whatever is at that address, I want you to look at the 4 bytes or 8 bytes or whatever that are subsequent to that address. And if they ever change, I want you to break into the debugger, right? And so then I hit OK, and then I run, and off we go. And now if those were ever changed, it would break. They probably never will change because they're only edited at the beginning of the program, so that breakpoint will probably never hit. Now that's a very hard feature to implement, again, unless you are kind of familiar with Windows internals and some of the more fancy stuff, because I don't actually know if tool help has that in it. It might be that the tool help library has that in it for you, So you may just be good to go, but it might not. And if it doesn't, then what you would actually need to do to implement a feature like that is you actually need to use virtual protect to protect the memory pages where that pointer exists, and you need to get page fault. You used to put a page fault handler in that every time someone writes to the page, it'll fault, and you look to see whether or not they were trying to write to that location. And if they weren't, you allow the write and reprotect the page, and if you weren't, you don't. It's actually kind of complicated, right? It's not rocket science or anything, but it's definitely systems level programming. You got to know systems level stuff to be comfortable with. I almost never use that. It's a great feature if it really worked better. I find Visual Studio's itself seems kind of buggy to me, and it's unreliable, so I don't tend to use it. If you had a really great one, I think maybe it would be cool, but it's pretty far down the list of things that I think are cool and interesting. It's not even really one of those, so it's more of it helps certain bugs. It makes it really easy to find them, and so you kind of want it when you want it, but the times you want it is very rare. That's I guess what I would say. So yeah, but obviously you can see why it's cool, because if you have some value that's changing and you just can't figure out who's changing it because it doesn't seem like it should be changing, you set the data breakpoint, you run from where you were, and you go, that's the guy, right? It like pops up and you see the breakpoint's like, this dude changed it, I forgot about that code, right? That's a bug, right? Or whatever, you know what I mean? So that's basically what that's for. So that's sort of, I think that's most of the breakpoint stuff that Visual Studio has. Let me just see if there's anything else. Yeah, okay. So I was going to talk about this. I didn't know if Visual Studio had it or not. Let me see here. Yeah. Okay. So yeah, let's talk about these other two. This one, when hit, is kind of useful. When hit does is it says that if you hit this breakpoint, instead of stopping the program at this point, what I might want to do is say, let's log something, right? So every time when you pass through this point, when you hit the breakpoint, the debugger will wake up, but instead of well, I guess it depends whether if continue execution is not checked, it'll actually stop as well. But if continue execution is checked, it's like, don't even stop, like don't even show me that you stopped here. All I want you to do is output this to the debug stream, right? It allows you to embed things like what the value is of a particular variable and stuff like that. And you can see that that's a very advanced feature, but you can see why it'd be useful. It basically allows you to construct a logging mechanism just in time, right? And so that's kind of a cool thing to have. Again, I never pretty much use this, but some of that is just because I'm not used to having it, and I'm not used to having it be reliable. So, maybe I would start using it if I thought about it more. So there you go. So that's what that feature is. Again, not a particularly essential one for me, but you can see why it might be interesting down the road. Okay. And so then the other one here is the filter function. And again, this is just basically adding a condition to it, which is saying like, hey, I might set a breakpoint, and I may only want to hit this breakpoint when a particular thread or a particular machine name or whatever process is running it. So maybe I'm debugging multiple processes at the same time or something like this, and I don't want you to stop at this breakpoint on one of the processes, but I do want you to stop at the breakpoint with the other one. Again, I pretty much never use this, but you can see why it might be useful. So those are like pretty far down features. Those are not features that I would consider particularly important at first, or possibly even for quite some time, because there's a lot of more useful features out there than those sorts of things. Okay, so that's breakpoints, and there's not much more to them other than setting, unsetting, being able to list them, and being able to do it by function. And mostly everything else is gravy. And a lot of these features, like I said, I get by without. So, if you have them, great. If you don't, no problem. They can be a long time coming, and it wouldn't really stop my ability to, I would still switch, right? I'd switch as soon as you just got set, unset, and set by function name would be enough for me to switch probably for 99% of the debugging that I do. So that's the breakpoint situation. Output obviously is fairly useful, and all output is the ability to capture the output of output debug string. And so that is, I think, something that tool help will allow you to do. That's just in your code. If you type literally, if you do an output debug string and then something like this, it shows up in there, right? So being able to capture the debug output of a program and show it in the debugger somehow is obviously good. Not a super critical feature, but probably not a hard one to implement and fairly useful. So I would say you probably want to get that in there if you can, right? So that's mostly all of the pre-setup stuff. Meaning those are the things that to get the without data inspection. That's the basics of like running the program, setting the breakpoints, being able to step through the code, that sort of stuff, right? And that's about it. Did they not have a breakpoint count in here? Because I want to talk about breakpoint counts as well as a nice to have feature. But I don't remember if this debugger supports them. Meow, 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 meow. There it is. Okay. So let's talk about these. Hit counts on breakpoints are a much easier feature to implement than some of those other ones that I said I don't really care about that much. Hit counts are easier to implement, and I do care about them a little bit more. And I care about them enough that I think they might be interesting to pursue as a fairly early feature, because I think without very much work, you could get something much better than Visual Studio's. So what Visual Studio does in general is it allows you to say, for a particular breakpoint, I might want you to only break at this breakpoint after a certain number of runs through, right? So I might say like, okay, I got the hit count, and I got the hit count to be, 10. So I only want you to do this after I come through this code 10 times or something, right? And the reason that's useful is sometimes you're like, well, I'm in a for loop and 250 of the things work right, but the 251st works wrong. And so getting back to that point in my program can take a long time, and I don't want to sit there and have to do that myself. So what I typically do these days, because Visual Studio is kind of weak, like I said, is I just put my own code in. I just make a new build of the thing where I put put a counter in the code and break myself. But if this were easier to do and better, I might use this more. And so here's the thing. You want to be able to say stuff like, I want to go n times, to hit it. And that's usually pretty good. But the problem is usually you want to break somewhere else after you've done some other thing, right? So usually the problem with breakpoints is hit count is usually not sufficient. So usually what I want to do is I want to do something that's more like break on this breakpoint after you pass this breakpoint, right? And let me give you an example of why I think this is more useful than hit counts. And hit counts are, like I said, very easy to implement. You probably should implement a hit count because it's just a counter for if you've got breakpoints working, it's pretty trivial. And this other feature I think is also pretty trivial to implement if you've got breakpoints working at all. So to give you an example of what I mean by sort of like a dependent breakpoint, is that let's say I have a function that's called very, very, very frequently, right? An example for this one would be, let's say push bitmap is misbehaving, okay? Well, push bitmap is called everywhere in our program. Everyone pushes bitmaps. It's called all the time. I'm not even out of the intro sequence and I'm calling it all the time, right? So if I have a particular version of push bitmap that I want to see, it's really hard for me to set a breakpoint in there because it's always called. So what's kind of a nice thing to be able to do is to say, oh, well, I want to see the call to push bitmap that happens after I do, debug end interact or whatever, or like right after this, right? So I want to be able to set a breakpoint and say, this breakpoint, I don't actually ever want you to break here. I don't need to stop the program here. I just want you to say, if you haven't passed through this breakpoint yet, don't activate this breakpoint, right? Does that make sense? Again, not something I need. I've gotten by forever without it, but it would be nice to be able to set up dependent breakpoints, because then you could do stuff like, oh, I need to break in the receiving routine for this thing, but only once I've gotten to the state of the program where I've gotten the acknowledgement packet or whatever. So I can set a breakpoint in the acknowledgement packet routine and say, this is a prerequisite for this other breakpoint over here that's in the receipt routine, and then I can just hit run and bam, I'm right at the thing I actually wanted, instead of having to do this whole monkey business of me like unsetting the breakpoint, hitting F5, getting to the new breakpoint, setting the old breakpoint back again, and then hitting F5 again, and blah, 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 right? So you can see why that's kind of a relatively compelling thing for breakpoints to be able to have. It's like some kind of dependency system, which, again, not that hard to set up once you've got breakpoints working, as compared to some of the other stuff like condition evaluation, which is pretty advanced because you have to be able to actually evaluate an expression, which is a lot more work. Okay. So let's talk about viewing things. So once I'm into the program, I typically, what you see on Handmade here is very similar to the way that I typically will debug in general. So I typically do have basically exactly what you see here. I have a call stack, and oftentimes I like to have the call stack expanded out quite a bit if possible, like on a bigger monitor. And you can see the stuff that the call stack basically displays. It displays like where, what module I'm in, right? Handmade.ic, the Handmade DLL, the kernel, whatever, right? It says the module, it says what function I'm in, and then it also can tell me, and I usually, like I said, turn this on, and when you have a bigger monitor, it actually works a little bit better. Of course, Visual Studio has not figured out that there's such a thing as being able to wrap lines. So, what are you going to do? You can't actually read most of it, but you can see here that you can say, oh, show me what the parameters are to the function, right? And, oftentimes I might just do that because I typically know what the different things are, but you can kind of see how that's sort of nice. Where you're like, oh, what was this stuff called with? And it just kind of tells you. Again, not super essential there, but probably not so hard to do. Either way, really the important part is just that you see everything. Like if you just got that, I don't care about this in any way. That's irrelevant. So this column is useless and not necessary. This is all you really need, but you usually, I do like to be able to jump like sort of scope-wise around as well on this, and we'll talk about that in 1 second. But in terms of display, this is all you really need. Nice to have is being able to, nice to have is being able to do the values like this, right? So that's a nice to have, but is not essential. This is sufficient. I'll go ahead and turn that back on. So that's a nice aspect of the call stack. I don't use locals pretty much ever. In fact, I don't even know why they're still on here. I don't use locals, and modules I don't really use either. So locals I couldn't care less about. If you want to do locals, I literally never look at it. It's irrelevant to me. I don't look at it ever. Now, pie in the sky, again, just to mention things for far down the line. Obviously, if you do have the ability to browse locals and stuff like that, then, there's a lot of things you could do that would make debugging a lot easier and better. And I don't know why nobody does it. When I step to a place, since you know what all the locals are, go back through the source code, and anytime you see one of those locals, dim out the actual name of it and put the value of it on top of it, right, in a brighter color or something, right? So, right, just show me what the value are. Or I have a big monitor at work, right? Draw the line again a second time and put the values in place of the names or something, right? Why don't debuggers do this? I have no idea. It's so obvious. Like, why do they make you look over here and at the other? It doesn't make. I have no idea. Point being, if you do have locals, the locals window, in my opinion, is useless. I don't even know why it's there. But if you did have locals, you could do something great with them, which is just put them in there so that you don't ever have to worry about looking at something. If it's a thing that's right in the function that doesn't require any work to get at, then you can just go ahead and get it. Like this, why am I having to do this? Why do I have to manually mouse over this thing to see it, right? It doesn't make any sense. So anyway, if we come through here, and I want to start inspecting variables, I typically use the watch window to inspect the variables, and you see me do this on Handmade Hero all the time. And the way that I do that is I like to maintain a watch list that's basically just the stuff that I'm working on right now. So I'll typically look at some things in there, and I want to be able to build, expressions up out of this. So typically what I'll do is I'll start with a struct, that I'm looking at, such as a tree, and you want to be able to navigate through the values of the tree. This stuff is pretty okay the way Visual Studio does it. It's not great, but it is nice the way that they put values and stuff like this. What's not great about what they do is they tend to clog up this view with things that aren't super relevant. For example, if I have tree, that's a pointer. It is kind of nice for me to see the tree address here, but it makes it difficult for me to see this information, right? And also the precision with which they print out floating point values is so huge, you typically can't see many things there. So I feel like a little bit more conscientiousness about printing these out would go a long way. For example, get rid of all these zeros, because they're not meaningful. Don't print this out so much precision. Try to maybe fit the things in a little bit better way. Also, similarly, like I said, I typically have a really big monitor at work. Maybe use 2 lines for it or something. Have some intelligence about how this printed out would probably be a good thing. I never use this, pretty much ever, so I don't care about it. It's obviously a nice thing to have. I think people probably would like it if it's easy, but it's irrelevant to me. I almost never use it, so I wouldn't put any weight on that at all for the most part. All right. So in here, like I said, I need to be able to sort of navigate down through things, and presumably collapsible lists are a good way to do that. I haven't thought it through too much. Maybe there's better ways of presenting this information, but you need to be able to do that basic operation of navigating through structs. And then when I want to see something for debugging purposes, I often want to pull it out. And so being able to pull out a thing and get an expression that evaluates to the thing that you were picking is pretty handy. That's a nice thing. And again, that's predicated on being able to actually evaluate expressions, which is going to be kind of hard. So that's a tough feature, but it's a pretty necessary one because you need to kind of be able to do that in order to debug effectively at the limit. So you need to get there eventually. But again, once you get basic expression parsing, it doesn't need to be the world's fanciest expression parsing, but just something basic that allows me to do, I can add the memory, move the memory over or whatever, go forward 1, back 1, whatever. And then address things, maybe I want to see this +2, or whatever, and off you go, right? So that stuff obviously is pretty good and useful for debugging. The other things that are pretty useful that you can do in here, and I don't necessarily know if I agree with the way they decided to implement this, but the feature is good, is being able to see multiple values at a time. So being able to put a (16) and see lots of things is pretty helpful, because a lot of times I'll have a pointer and I want to see several things that come after the pointer. So I want to see if it's pointing to whatever, if it's pointing to a vector, if it's an array of vectors, I want to see all 16 vectors from where I start or something. I want to be able to get that, right? So that is a kind of nice syntax. And there's also I never remember it, but there's other syntax here that's useful, like being able to say what type I want to view this as is also pretty handy. A lot of times I have to do it this way, I cast it to something, and then I'll do 16, so now I can see it as 16 bytes in a row, right? Oops, I didn't do that right somehow. I'm not sure how. Thought I did. Maybe I didn't. There's a better example. So here I've cast this pointer to a char star and looked at 16. That shows me what the values are as if they were a bunch of characters. That's really helpful as well. I don't know that this is a good way to do it necessarily, but it's, again, if the feature is being able to say, I need to see this value as a set in this format, right? If that makes sense. And that's really all I do for watches that would be the basics, is expressions plus being able to say what type and how many of a thing to show me is really it. This watch window sucks. I mean, I can think of an infinite number of things we could do that would be cooler, but it's enough to get my debugging done, so those features are the features. Being able to type a register in here, I would say, is pretty nice. So being able to say that I want a register, one of the registers by name, is a nice feature too. I don't think that having a register window, I don't know is really all that logical. In fact, I don't really think there's any point in having a register window. The thing that makes a lot more sense to me is just having some kind of shorthand in the watch window that you could do that would say, I want this set of registers to show up here. So let's say I want all the XMM registers. It would make more sense to me to just be able to say like XMM, I don't even know, I'm making this up, but something where I just said, show me all the XMM registers, and then this stuff just showed up in the watch window as a little drop down. Because I feel like the watch window, you don't need a register window and a locals window and a watch window and all that stuff to be separate. In fact, honestly, you don't need most of these to be separate, in my opinion. They could all just be part of the watch window where you just type in a special thing here and you get a drop down of the special thing. So if I wanted locals, I'd just do, locals or something. I don't know what it would be. It'd be some special thing. Or maybe there's just a right click menu and I just pick locals out of it and then there's a locals drop down, right? But it just doesn't make sense to me why they have to be different windows, because maybe I want the locals showing up down here and then the other stuff here, or I want some of the registers here or whatever. You get the idea, right? It just seems like it's all the same thing. You might as well stick it in one window and allow you to configure it cleanly using, using a regularized approach, right? And so I would say like the same thing is true of something like modules. Again, modules is just a nice to have, not super important, but it's nice if you're doing more advanced system level debugging to be able to come here and say, hey, you know what? I would like to, I'd like to see a list of all the modules that are loaded right now, and where they were loaded from and that sort of stuff. Again, that's the kind of thing in my mind you could just do in the watch window or something like that, right? And I'm going to talk a little bit more about that in a second. So again, modules window is not particularly important. Threads window is unfortunately a little bit important. Oh, and register window, like I said, not particularly important because I think that should just be, being able to get at the registers is important, but it should just be in here somehow. I think that's the better way to do it, rather than having a separate register window. Okay, in the threads are relatively important, unfortunately. The thread window in Visual Studio is not great, and honestly, I feel like I haven't thought enough about what I would want in a good thread window to really give recommendations, so I'll simply say what the basics are. What I need to be able to do is I need to be able to click on threads and see where their current execution pointer is, which is what I'm doing now, right? I need to be able to see which one of those threads I'm currently viewing. So when you're showing me like an active, here's where a thing is, I need to be able to show where the cursor, where it's at. Just so I know which one of the threads is I'm currently looking at. And really, that's all I really probably need is the ability to see what the threads are, where they are stopped, what function they're stopped in, and be able to jump between them. That's probably all I really need. In terms of features that are more advanced, yeah, showing like what module they were in and what their priority was and all that stuff is all obviously great. If you've got that information, it's always good to have. But if it wasn't there, it wouldn't be a huge problem. Being able to expand to see their stack is also obviously nice, but again, not a huge deal because I can always just double click on it and see it in here. So it's like, those are sort of nice to have, but I don't really know how important that really is. And I don't use it that often. So I'm not sure I would really care about anything of that. Stuff that I would care about is the ability to say solo this thread, for example. Because in Visual Studio, I always have this problem, and maybe I should just read the manual or whatever, but typically I get in a situation where I've got a bunch of worker threads, they're all doing stuff, and I want to single step one worker thread. And all my worker threads are stepping, and I can't, and I like go in here and try to freeze them, and it doesn't work right, and I don't know, I'm just not using it right, I'm not sure. So what I really want out of this window usually is just the ability to say freeze all the threads except for the one that I'm on. I'm going to single step it for a while, and then be able to do the opposite, unfreeze all the everything else and go back to normal. That's what I would really use the most. The ability to individually freeze and unfreeze threads, while obviously if you could do the other one, you might as well include that as a feature. I don't really know that I use it that much because it's such a pain in the butt. And I would rather have something reliable that I could just go like, I'm just stepping through this thread now, just only step this thread. Okay, now step everything, if that makes sense. Okay. So that reminds me I should mention one thing, which is that when you are stepping, typically that's just a thing to think about when you're designing this thing in general, is that there's two ways of stepping the program. One way of stepping the program is step to the next thing that gets to the next line of source code, right? Like I say, hit step over. Step to the next line of source code that gets hit by any thread or by this thread. And I feel like it would kind of be a good thing to just build that in. So maybe even instead of the thing that I'm talking about where I would do like freeze and thaw all or whatever, maybe you could just do a thing where it's like, hey, the step function actually, there's two different ways you can do your stepping. Any step can be told, when I'm binding my keys, I can say, this does step into on one thread, or this does step into on any thread. And then, something like this. I don't know that much about that. I tend to keep my multi-threaded programming relatively straightforward, so I don't tend to have to do a whole lot of multi-threaded programming. There's other people who do a lot more. If you ever want to do more pie-in-the-sky stuff with threading, you probably want to talk to someone other than me and find out what sorts of stuff they would be interested in, right? And similarly, I don't often have to debug multi-process stuff, so the ability to run like two processes at the same time and be more specific about which one you wanted to see and who's, blah, 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 that's also something that, while I can sort of speculate what might be the right thing, you probably would want to ask somebody who does more client-server side-by-side debugging, because they're going to have probably more insight into what would make more sense there. Okay. So last couple things on this, on viewing information. One of the things that Visual Studio does really poorly and that GDB does much better is, if you notice, when I move around in these stack frames, there's sort of an implicit thing that we didn't talk about, but that's important to understand as you try to make the debugging system better and more powerful, which is that what these watch values mean is actually a little more complicated than it might seem at first. So, for example, let's say I go back to my main thread here. Here's my stack frame. So here is debug end, right? And inside debug end, there is a value called input, and here it is. Now inside debug draw main menu, that value does not exist. Okay? But you know what? I could do it even better. Let me do one even better. Debug state. Okay. So in these two, debug state is, I'm gonna do it even one better. I'm gonna take the address of debug state. Okay. What I'm asking for to show in the watch window here, right, is I'm asking you to look at the symbol debug state, and I'm asking you to tell me what the address is of that symbol. So what is the address of debug state, right? Now, its address, because it's a pointer, it's going to be different depending, even though debug state exists in both of these stack frames, right? Its address is going to be different, because on here it's stored in one part of the stack, and for this function it's stored in a different part of the stack, right? So each one's different, right? Debug end, debug draw menu are two different ones. And you can see that reflected here. When I move between the two functions, you can see it change, right? It's db0 here, but it's EB0 here. Two different addresses, right? And that underscores a very specific thing about the watch window that I don't think Visual Studio does very well, which is that names are not enough to tell you what you actually wanted to see. Yes, there should be some default behavior, like if I type this thing in here and don't specify anything else more complicated than that, I want to see in the current scope, whatever that is, I want to see the value of this. So when I click and change what the active scope is, which is kind of what's happening here on the call stack clicking, right? Which is why I said I want to come back to this later. There's this sort of concept of the active scope that I'm in. the watch window changes to reevaluate all of its expressions in that new state. But that may not have been what I actually wanted to do. What I actually may want to do is see the value as I step through my code. I may have wanted to see the value that the previous stack frame had. I might want that to persist. Okay? So let me give you a very simple example of why this is important. It's actually very important, I think. And like I said, it's not done particularly well in Visual Studio. Visual Studio is not a good thing to look to, if you will. All right. So here we are in our little test stupid program thingy. So if I run it, here we go. And I step into foo and I return and whatever, right? Okay. So here is a typical situation in which one might find oneself. So let's say I do something like this, where I have int b equals 5. And foo is now going to take the address of b. Okay? So now we have int star a over here that's coming in, and I want to add the address of that to int b, and then I want to return it. Right? That's what I would like to do. So now I come in here and I say, all right, yes, please build it. My lord, that is slow. Okay. So now I come in here and I say, well, okay, I'm looking at b. I see that its value is 5, right? And so that's all good. Oops, I meant to step into that. I step in here, and you can see now I've lost what b is. I don't know, it's gone, right? Because there is a b in here, and it's masking the b that I was actually trying to look at. I wanted to look at this one, okay? Now you may ask me, why do you want to look at that one? You know it still stayed 5. Well, okay, not necessarily, right? Because what if now I do something like this? I come through here, I say, okay, there's my b. I want to watch, because maybe this is a much more complicated program, and I don't know, this isn't getting set right after foo, and I don't know why. So I step in here, and I'm stepping through, and I'm like, ah, crap. I lost the value. It's gone, right? And it's not what I wanted to look at. So I wanted to see when it was getting changed. So what I have to do in Visual Studio all the time to make this work is I need to do this. I need to take the address of the thing that I'm looking at. I have to copy it like this. I have to cast it to the thing I was actually trying to view. And now I get a permanent version of it, right? And so then I come through here, and now I can watch and see it change to 6, which is what I wanted, right? So the ability to do something where I come in here and I can just right-click on this thing and say, like, pin it would be awesome. But I've never seen any way to do that, right? In Visual Studio. Like, I can't, there's no way to just say, this is supposed to be, you know, oops, that's not what I want to do. How do I undo that? No! Why would you do that? God. Seriously? Okay, fine. Whew. All right. So anyway, you get the idea. So implicit in all of these things with the watch window is kind of this slightly complicated underlying assumption, which is that there is some framework for evaluating what the expressions mean. And what I think you probably want to be true as you get into a more advanced debug scenario is you want to be able to say for any given watch expression that either it's using the default, which is just whatever it is, and maybe that's the same as Visual Studio, which means whatever the scope is that you're actively in, and that's like some notion that the program keeps, and when you click on things in the call stack, it just changes that default, right? And when you step, it sets the default to wherever the step landed, right? So by default, anything in the watch window is just going to evaluate as if it was there, but you can always pin its scope, or maybe there's some shorthand to set its scope to something from the call, or maybe you can drag and drop from the call stack onto it. I don't know. but ways to say that this thing is meant to be evaluated in a particular scope and it's frozen there, don't re-evaluate it. Other examples of pie in the sky stuff, there's, I want this evaluated in my parent scope, whoever that is. So go up one scope always from wherever we are right now and tell me that value, right? That would be good for example, debugging recursive functions. Maybe I want to see this one and the parent one and the parent one. So I can just say, okay, B, 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 I type B 3 times, and then I say parent scope, parent's parent scope, or something, right? So you can see why those things would begin to become more powerful. So rather than copying Internet Explorer's kind of broken way of doing that, which is sort of this weird implicit frame that you can't really ever tie down or refer to in any way that I know about, you could kind of have this more explicit notion of where it's coming from. And by default, it's sort of the same as the way Visual Studio or every other debugger does it, where it's just wherever the active area is at that time. You could instead have these ways of like being more explicit about that. Okay. So I think we're almost done with this complete tour of all the features. So the memory window is, I think, falls into the same category as I was saying with watch window stuff. And what that is I don't know that you need a separate memory window. I feel like you could just do like memory and then some expression here that evaluates to a pointer. So either you just type in some address if you want to look at that address, or you type in a pointer value and whatever. I don't know. I mean, like I said, you guys probably have ideas about how you implement stuff, but some way of just saying that. And then there's just a size. I can just resize a thing and get as many memory. Like I don't know why I have to have a window, right? I should just be able to be, these things can be variably sized, because I want that anyway. Like I want to be able to see more of this. I'd like to be able to variably size this to multiple lines and then have it word wrap or something for me, right? Same thing with memory. I want to be able to just do that and then show it in that window, because if you could do it here, you can do it there. Just make that happen, right? And so memory is really basically really straightforward. That's just going to dump memory from an address going forwards, right? And really the only thing that you want to do there is be able to dump it in some kind of specifiable format. Maybe I want to see it as 4-byte, 8-byte, little endian, right? Just the basics here, exactly what you see here is pretty reasonable. And being able to see a sideband that has text in it, it can be pretty handy if you're doing sort of debugging of things that involve strings. If you've never seen what that looks like, I can kind of show you. Like if I come up here, what you can see is, like I'll step, I'll just take a look at the address of text. Oops. So I'll just type it in myself. OX17AEA0. If I come in here, you can kind of see that it's sometimes nice to be able to have a text sideband on it as well, because then you can sort of see that like, oh, I wouldn't have picked out the pattern based on this, because really all I see is these FEs in here. But if if my eye will immediately see, oh, that was where the string was, because I can see it there if I was like trying to scan through this stuff, right? In fact, there you go. I can see another string that was there that I never would have known it if I was just looking at this, but having a text sideband can help you in that sense. So yeah, I think that's basically it. There's a lot of stuff involved in a debugger, but the basics, like just getting those basic things that were the things I said were like the number one priority, I think it seemed like you already had most of those actually. The watch window is the harder one because you tend to need some expressions for that. But that's the situation. What I wanted to mention as an architectural note, I'm trying to think if there's anything else I'm missing before I move on to the architectural note, but I don't think there is. I think that's mostly all I use. I don't use a lot of Visual Studio. I think that's all the features that I actually use. Very, very few features. But like I said, if you get it to the point where I can use it on Handmade Hero, we'll just start using it on Handmade Hero, and I'll be able to immediately note anything where I'm like, oh, I wish I could have done X and I forgot about that. But I think I've just covered basically everything, including a bunch of pie in the sky features. So I think that should be able to be prioritized into a list relatively easily. So something that I want to mention as an architectural note, that I don't think they noticed in Visual Studio, but I think that it's important from the standpoint of being able to make a good debugger that's extensible, multi-platform, and easy to write and implement. One thing that I want to point out is really, I think that you can get a ton of leverage, and I studied this problem a bit because I did a little bit of consulting on the RAD debugger. And I studied this problem quite a bit, and what I realized is that basically 100% of the features that I ever see used in Visual Studio can actually, in terms of UI and debug display, can actually be sort of abstracted away in a very straightforward fashion. And that fashion is just one of these like watch windows where you have some, it's just a matrix display, right? And especially if we expand it to consider the thing that I was talking about before, where you could have, you don't have to have it, each one be only one line. They can be like variably sized, so you can get something like this in there. But something that works this way, where you have some number of things across the top, and then some number of elements that are coming down the side, you can do some interesting things if you actually just sort of start thinking about this as the primary way which you expose data. Okay? And the reason that I say that is, I'm not sure I can really go into it in enough detail here to maybe make the most amount of sense, but I'll try. Let me load up my trusty Blackboard here. So consider the following thing. If I have a UI layer, right, and I have the debug services, okay, and this is the primary architectural thing that I just wanted to kind of get across, then essentially what I'm trying to figure out is I'm trying to figure out what the API looks like across this boundary. And different choices for how you pick that API are going to have significant effects on how complicated it is to write this, and how complicated it is to write this, and how much you have to touch one or the other every time you want to do something. Okay? So the primary goal when thinking about the architecture for something like debug services is you're trying to think about exactly how you can construct an API that will make it so that you don't have to do any unnecessary work, or very little unnecessary work, when you're implementing any given feature. So I'm going to start, and I'm going to, you know what, this is turning into a bit of a marathon stream, I suppose, but that's just the way it goes. I'm on a roll. Just bear with me. So the first thing that's, I think, important to realize is you're going to have a watch window, right? So you know that you're going to have something along the lines of, oh, okay, I've got foo plus 5, right, comma, or arrow, next, comma 16, or that nonsense that we had there, right? So the UI layer is going to be able to allow you to enter things like this, and that has to be sent over to the debug services layer in some way, right? And the debug services layer is going to have to evaluate that and say, oh, that's, this many strings. It's like 0, 1, 2, 3, right, all the way to 15 or something like this, right? And here's the data that actually goes in each one of them, right? So that you have to do. So what I started to realize when I was looking at this architecturally is that once you have this ability, you can actually build everything a debugger does on top of it, right? Because if this is something you can do, then if you want to implement something like, say, the thread window, instead of implementing that as a totally separate UI thing, what you can do instead is just make that be an expression, right, that gets evaluated in the same way as a watch and passes back, right, when it's going to do the thing, is all the threads. Okay? So in order to make this work in a way that extends nicely across all of the different UI things that you might want to generate, all you really need to do is realize that there's more than one column to the output of the watch window, which there already sort of was, right? Even when we were in here to begin with, Okay, there's already this type field. So we already know that the watch window itself, right? Where did that go? There it is. Actually, you know what? I should leave that up because I'm going to talk about that some more. So the watch window itself is already something that when you when you are talking about its contents, what you're talking about is sort of expressions. There we go. You're talking about sort of an expression here. What was it called in this case? Okay, so I'm just gonna use their exact terminology. If we were trying to reproduce this exact window, right? We would have a name, we would have a value, and we'd have a type. Okay. So what we know is the API that we're actually calling is going to have to return us 3 separate fields to the UI so that it can place those 3 things across, in its window. So if you just generalize what these are, right? Meaning that as long as you don't do something where you're just like char star, name, value, type, and this is the struct that I pass back. If you actually go, okay, I've got this struct, here's my struct that's coming back or whatever. It's, I don't know what we want to call this, but this is our entry or whatever, and the entry has, a column, star first column or something like this, and I don't know, entry. Next entry. So assuming that you have something like this, where you're just going to get these columns back, and you have these, you're just going to have a chain of entries, or a chain of columns, or something like that, then whatever you get back here, the debug system can just always talk back to the application in terms of something very simple like this. And the debug system can add as many things as it wants. It can make a module listing that way. It can make a thread listing that way. It can make a memory listing that way. It can make a watch window that way. It can make a register view that way. It can make anything it wants that way. Because all the UI system needs to know is sort of these matrix listings, right? It just needs to know, here's what I'm going to put in my columns, because every last little thing in this system looks that way. There's nothing in here like this could easily be organized that way, right? This thing already is organized that way. This thing is organized that way. This thing is also organized that way. So everything can be done in terms of these sort of matrix things, however you want to communicate that back and forth, everything can be done in that way. Even the call stack could be done that way if you wanted to, like you can sort of see here, right? And even for things that don't quite fit in that way exactly right, like where you have a variable number of parameters, even that you could do what they do here, which is stick it in this way, or you could even say extend this notion to the concept that there's multiple, that this doesn't have to be the same number for everybody. So then these could actually be their own entries in here, and you could just make up a different kind of view. We're writing this all ourselves, right? Make up a different kind of view that just kind of has as many as it needs to have, and then they're discrete things that you can kind of size or do whatever you want to, right? So you could even do more than that. Okay. So if you imagine that you start to generalize it this way, you can bake down what the UI debug protocol is. You can break that down into something very, very, very small at the end of the day, right? It can start to be very very, very compact, because you can get the debug system can enumerate lots of things to you, and furthermore, you get a certain homogeneity out of this, like the thing I was talking about before, where I don't really want a separate memory window anyway. What I want to be able to do is be able to get any of these views happening in here so that I can customize what I'm seeing and pick out individual things. So a lot of times we kind of want them all to be watch related anyway, right? Okay. So once you start thinking of it that way, you can start to get kind of a little more general, a little more cerebral about how that UI stuff works, right? Because what you can do is say, well, a given line of this, let's think about what happens. The debug system, I know, gives me back certain information for every element, right? So let's say that type of element is a thread. So I make some imaginary request. We're not going to talk about how it works quite yet, but I make an imaginary request that says like get thread info, right? And that maybe perhaps comes back with, it would tell me for this particular thread all of the stuff that's in this window, right? So it would tell me the process ID, it would tell me the message ID, the category, the name, the location, the priority, right? Well, what you can think of that as being, if it looks something like this, is you can think of that as just being a chain of named value pairs, right? You can think of this as just being, all right, I've got an ID. So let's take this and break this out. Let's say we have struct column. I can just say, all right, here is the column name, and here is the column value. Okay, that's what I've got, right? And then obviously we're going to have a next pointer if this is a chain. You could also equivalently make it an array. I don't know, however you want to do it. I don't care. I'm not trying to tell you how to structure your code. I'm just giving you what the ontology looks like here, right? So if I have this example where I've got these columns coming back, I've got ID, manage ID, category, name, location, priority, right? What you can do is realize that really this is just sort of a struct, right? This is as if I'm passing back a struct that just has this information in it. And I could make my watch window be a lot more interesting by saying what it is that I wanted to pick out. So if I want to know what the current thread's thread ID is, instead of having to switch back to this window and see this information, which I don't actually care about, I could actually say, whatever the special thing is for current thread, dot whatever the name is of this column, right? Which is ID. You know what I'm saying? So you can start to play with these things in a way that starts to collapse on itself kind of really interestingly. You can start to say, well, maybe we only really have one thing, which is we just have whatever the thing is that allows us to inspect this watch window in C++ types, right? Because we know we have to have that, right? If the user defines struct foo, and it's got an int x and a char star y in it, we know we have to be able to display that. And we know that if I have a foo a, right, then I need to be able to type a.y in the watch window and be able to see it. So why not just turn everything else into that, right? Why not just have everything that the debugger ever exports, just pretend they were part of the watch information? Because then you only have to write one window, and you get every other window for free. Okay. Next question. How do you actually operate on these, right? Well, again, that can just be part of the UI language, if that makes sense. What you can do is say, all right, let's take an example of how we might actually start coding this up, right? So here's the thing. We all kind of understand what we're talking about here when we say I might want to inspect struct foo, right? And furthermore, we could all imagine a more interesting way of creating watch windows where these things up top, value is like, imagine these columns, right, are more like, here is the thing that I'm inspecting, right? Here's its name in the debug system, right? And value is saying, show me what you would print out when I ask you for the general information about it. So it's like the default printifier of this thing, right? So maybe if I'm saying it's a pointer, I get this debug printout here like it does, exactly what Visual Studio does, which is like, I guess this might be what you might want to see, a little bit of the struct it's pointing to, whatever, blah, 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 right? And then I also have a type field, which is saying, look up what the type is, tell me what the type is. So this watch window, what it's basically doing, imagine these are just accessors off of the struct, right? So a pointer is a struct. All pointers are effectively structs, right, that have values off of them and types off of them, which is the things I'm printing out. But alternatively, I could have made this column just be a, right, like in the case of, y in the case of a foo, and it would print out that member of that struct. So like if I wanted to make the watch window that for some reason only ever prints out things from foos, right? It's my foo watch window. But you could imagine this actually being useful. Let's say I wanted to make a vector watch window. And whenever I put a vector in here, it shows me a column with the x, the y, and the z, right? But not the w for some reason. And it's their four-dimensional vector. So I didn't want to show that one. Who knows? Or maybe I just want the x and I want the z or whatever. So again, if these things are actually just things that tell it, if the column header, essentially, is the thing that tells it how to evaluate the thing that you have, right, that came from here. And you can make as many of those as you want. You can start to create things that will allow you to build any UI it was that you had in your mind by doing nothing other than just typing essentially watch expressions into the columns. So the thread view would literally just be a thing that says, oh, okay, well, and actually I'll tell you one more thing then. Okay, so the last thing we need to complete this puzzle is the concept that we need an enumerator that tells us what all these things are. So one of those enumerators is obviously just watches, right? Which is like, there's something like underscore underscore watches, some symbol that's just like all the watch symbols. So it's, you know, an array or whatever, right? So we have watches and it's got a count. It's an array that has a count, right? It's a fake symbol that the debug system reports as if it was a constant array. And so when we create one of these windows, whatever they are, they're just a generic window now. The generic window has a thing in it which says this generic window uses this symbol as its lister down the side, right, as this thing. And then each row is just going to start by printing out whatever that value was in here, right? Okay, so for example, you know, in the watches, they're just strings, right? And so it prints out that string. Simple enough. Okay, then each of these, well, I shouldn't even say that. That's just what each row is. Then we go across each column to see what we will print out. If we want to print out just what the contents of the thing is, then we put that here. If we want to print out what its value is, which is how, you know, it's interpreted, we put that in here. If we want to put a type in, we put that expression in here. But any other expression that could start from the thing that was listed, I don't know what just happened to my watch window. There we go. Could also go up in here. So I could, for example, say, the value, whatever it was, my watch expression could be, value, whatever that special value is, or row head or something, I don't know what, +5 as a character. Maybe that's what I would actually set this column to be. And again, you don't have to write anything else to make this work in the debug system, because if you can just do the basic expression evaluation, the UI system will just drive it nicely by asking each time for all of those things. It's like, hey, okay, I need that, I need that, I need that, right? So once you get to that, you can see how you can make any window out of that. You want to make the thread window? Well, then you just have a synthetic variable that's the list of threads, right, an array of threads. And you export that from the debug system. And then in the UI, you just create a column that's each one of these sub things off of it. And the debug system exports threads as a struct, which has that data in it. And now you don't really have to do you don't have to make tons and tons of different ways of, you don't have to write any windows, right? You don't have to do any extra work. You just make one single way that you're comfortable exporting data across the boundary and exporting expressions back, and you can do everything, right? Everything can be worked that way. Anything that can be represented as some kind of a structured piece of debug information, which we know is everything, because otherwise there'd be things you could create in a program that you couldn't see, right? So anything that you could make, you can just make a fake struct for and export the thing you want to view as that thing. So whatever the debug system is getting, it just packages it up as if it was yet another thing that you watch. And then the UI layer doesn't really have to care. All it knows is basically how to make a watch window. And every window is a watch window of some kind, right? Same is true for the stack. Same is true for all this stuff. So now we get to the point of like, well, okay, but UI has to happen, right? How does UI happen? Well, a couple of different ways you can do that. But whatever you export across this boundary, when I say, I'm giving something back here, it's actually not that hard for me to give it a list of ops, right? I could say, here are the operations that I can do on this particular thing that I gave you, right? And furthermore, you could make those things be some kind of a standardized thing, but really you could just do, okay, like for example, depending on whether or not these things are easily identifiable across the boundary, which maybe they are, maybe they aren't. I think they kind of would have to be somewhat, you'd have to be able to have some kind of a cookie at the very least. But you could even do this in a relatively immediate mode transitory way by doing something like, okay, well, when the user right-clicks on this thing, I refresh the window and I iterate through it, and when I get to this one, when I talk to the debug system, I say, hey, this element is now active for user interface right now. So when I send something across the boundary, I say, this is going to be a user interface thing. And the debug system just says, okay, here's a list of operations I could do on this thing right now. So for example, if it was a thread, right, if the object in question was a thread, the UI system doesn't have to know what a thread even is. It just knows it said, hey, the user is asking to operate on this thing. What have you got for me? And the debug system returns, oh, I can freeze it, I can thaw it, I can solo it, I can jump to where it is, I can make it active, right? It just lists those things and just gives them an ID, like 0, 1, 2, 3, 4, 5, I don't know, whatever you want. And then all the UI system to do is allow the user to pick one of those and sends that back over. It's like, hey, the active thing, either I canceled it or I did this operation to it, right? Whenever it's done. And if you do it in that way, where you just open it up for action during a repaint or something like that, it makes it so that the debug services don't have to keep a lot of state around either. They know that there's only one person they ever have to be actively operating on at any given time. And so that makes it easier on the debug service side to keep what the, you don't have to have GUIDs for everything. You can just say, oh, I just store the state of whatever the last thing is that I told the person I could operate on and what the operations were I could do on it. I just need to store just that and only that. And when he tells me that they canceled or executed, either I do the execution or I just get rid of it. One or the other, right? So that's pretty simple. So you can even go to the point where now the debug services can export all the things that they can do without the UI layer even ever knowing what that is. And that can be pretty powerful from the standpoint of multi-platform stuff, where it's like, oh, the debug services on this platform allow you to do all these other things that you can't do on other platforms for some reason, or who knows. And the UI system doesn't even have to know. It's like, I don't know, I show the ops I can do, right? And you can make that a fairly rich pass back and forth. Like you could make it relatively rich in the sense that, it could pass back, pass back like whether things should be checked marked, like whether it's a Boolean toggle or an action, or, it could be, it could be relatively advanced if you want it to be. Okay, so all that stuff is fine. I'm just trying to give you some ideas here based on architectural notes that I made. Where's the rest of my stuff here? There's more things here. Yeah, okay, there we go. So let me tell you one last thing, and this is like all the debug download dump, I think, at that point. So one more thing that I wanted to point out is threading and asynchronousness. So as you go further down the road, right, you're going to get into situations where the debugger really wants to be async, right? Because let's say you extend this so that now somebody adds a TCP/IP layer, so it can send it back and forth, so you can debug a remote machine. Or on this particular platform, debug services are very latent, so some of the operations you may do may take a while to complete, and you don't want to hang the whole editor, right? So one way to approach this problem is to have a lock festival, and it's all kind of a nightmare and have lots of bugs and all this other sorts of things. Another way to do it is a way that I came up with when I was looking at the RAD debug architecture, and I think it's pretty cool. And it's called valid, stale, and invalid. So the way that this works, you could call it VSI if you want, or I don't know, Viz, IVs, I don't know, you can organize those any ways you want. The idea here is that the debug system, right, is kind of broken up into two segments, and you can kind of think of this system as maybe being three-tiered, right? So there's the UI layer, there's the debug local layer, and there's the debug, remote layer. So the way that I envisioned the system working is these two things kind of live in the same area. And this thing probably doesn't, right? So this thing might be its own thread, this thing might be its own process, this thing might be on another machine, this thing might be remote over the internet, who knows what this is. But this is the thing, essentially, that that the person who wrote me is and asked about how to debugging or what features we needed asked about. So this is the thing that like reads the registers and sets breakpoints. It actually does the work, the like low-level work of just getting memory and register state and controlling the flow of processes, right? But eventually, like I said, probably that system wants to, again, stay pretty simple and only do those operations, right? It probably doesn't want to involve all the UI, all that other stuff. It wants to be kind of small, and then, you know, on top of it, you take for coder or whatever, and you build out a system for grabbing all that information, displaying it, and doing all these other things. So this is the thing that might take a while. It might hang. It might be on another machine. Who knows, right? So this link, this is a slow link. Okay? And furthermore, it could fail. A good example of it failing is I asked to read this memory location. That memory location is not even valid, right? It doesn't even exist in the target process. It's null memory. It's illegal. It's not mapped. Who knows, right? So it's slow and it's unreliable, right, in that sense. This link is fast and reliable, right? So the idea is the way that this system works is that this part of the code is meant to iterate over the data in a single pass, in a single thread that always succeeds. And this thing updates it when it updates it. And you want to always know when to display those and to make this work properly and to never have any deadlocking and blah, 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 blah. So how do we do this? Well, my idea was what we do is when this system iterates over things, and I'm just imagining, let's say, like I said, don't want to tell you how to architecture code or anything, I'm just giving you suggestions and stuff that I thought about. But what's going to happen essentially, right, is there's going to be some iteration process. Like I said, let's say we take my idea here and do the generic window. So we have like, you know, expression 0, expression 1, expression 2, expression 3. And we've got row 0, row 1, row 2, row 3. So this is an, well, I guess it's really this way. So here's my generic window. I'm showing essentially the contents of this grid is what I'm displaying. I've got something that gets me these, and I'm going to iterate over this, filling in this expression with relationship to this source variable, then this one, and then I'm gonna go to the next one, and so on, right? That's what I need to do in the UI code, okay? So the problem is, when I go through here and I do all of these things, all of them might be latent. All of them might take too long. All of them might require a TCP/IP transmission to get information that's not available, and so on, right? Furthermore, some of them might not work. They might access memory that doesn't exist. Who knows? So what I was thinking would be the best way to do this is you do a pass over it, and you imagine this iterator, right? So, you know, I've got some for loop here. You know, I mean, like I said, I'm just making this up, but let's say I do something like, you know, we've got a row iterator thing called row, you know, and I'm doing a for of that, you know, first row, for some row expression that we remember that's the row expression that's what makes this window, right? And then I'm going to say, like, you know, while row is valid or whatever, or while row, let's just say it's going to be valid to, I don't know. You know, row equals next row. Right, so I'm just going to iterate over these rows. And then for each one, I'm going to iterate over the expressions. For like each expression, I'm going to iterate over it. Okay, and the expressions are part of the window. So, you know, this window thing has, you know, what its expressions are. Here's like all the expressions. You know, I don't know, maybe there's 5 of them here. And then it's got the row expression, right? So it's got this thing, and it's got these. So I'm iterating over these to draw my window, and I'm just asking the debug system, hey, Mr. Debug System, I need you to give me what this is, right? And so when I'm doing that, I'm going to make a call here, and I'm going to say, give me that information back. I need the text to display, please. Right? And so then rather than stall the pipe at this point and have to wait or be a separate thread that's doing refreshing, I think that's very error prone and dangerous. I don't think that's a good idea. So rather what happens here is when you make this call, when you say like eval for whatever this is, you get an answer back immediately. But the answer is tagged. Okay? So the answer is basically tagged with one of these three things. It says this is valid, this is stale, or this is invalid, right? And what valid means is I actually know the answer because I have the value of this code right here, right? Which is essentially just code that's responsible for caching whatever comes back from this, right? I have the answer and I know it's valid because we haven't changed the state of the program. We haven't stepped it or run it or anything, right? So it would come back with valid. Or it could come back with stale. And what that means is I do have the answer to this thing, or I have a dummy answer to this thing, but I know that we've changed the state of the program since the last time I read it, and I need to go read it again, right? And so it'll tag it with stale. Finally, if it just can't get it, it's like, that's not a valid, you're asking me for something that's in invalid memory, or you're telling me to read a file that doesn't exist, or who knows what you're telling me to do. Then it just returns invalid. Okay. Now what this thing does is when the UI repaints, for this window, it keeps a state. At the start of the state, it initializes it to valid, right? When it comes through here and it does its eval, it looks at the state that comes back from the eval, and it says if the state that comes back from the eval is stale, then my state is stale, right? What this allows you to do is this allows you to just update your debug system on a timer until nothing is stale. So when I hit the step button, I go through, and if I'm on the local machine, I probably just get all the information because it's probably just fine. So everything comes back as valid and I see it. Now I'm on a remote machine, the round trip time is 2 seconds or something, who knows? I hit step, it's like, I don't have any of this stuff. All the things turn, and they probably, you know, in here, when I draw it, I probably draw it based on this thing. So everything turns gray for it's stale, right? And I know that this window needs to be repainted because at the end of the loop, when I've repainted the window this time, I know it's stale. So I just set a timer and say, repaint this again in 1 second. Or however long I think, you know, you could even guess about that, right? You could even ask the debug system maybe, how often should I poll you? And maybe it knows that based on how often it's getting responses back typically. So then you just go, okay, set a timer. And you don't even necessarily have to set a timer. Maybe you just always have a timer going off every 100 milliseconds. And when that timer goes off, you just go, are any windows stale? Right? So I remember that the window's stale, I come back in and I'll repaint it next time. So then it just goes like, okay, I step, it's kind of gray, and then it like filters in as I get values as they come back from the server, and then until they're all black, and now I have them. So it never stalls my stepping. I can still step as fast as I want, even though the old machine is really slow potentially. But you know, I can only get back the information that I get back. I can only see it as fast as it actually comes back, right? And this also solves the threading problem, because what this means is that this is running on a different thread. Well, all it has to do is update that cache. The only thing that has to be thread safe is the locked update of this cache. That's the only thing. And none of the UI ever has to be aware of that, right? It can just swap out like pointers behind this thing's back, and it's fine because this is always sort of asking for and displaying that set of data, right? So this allows you to keep 100% of the UI 100% single threaded, 100% unaware of whether the thing that's it's running on takes a long time or not, and it's nice. Plus, it bakes in the invalid bit, so when it gets back one of those, it knows it can draw it in red, like whatever you try to do, I couldn't get it, I'm sorry, like it's not there anymore. And this, to me, was a very clean way of getting out all of that threading stuff and all of that weird like interlocking stuff where it's like, oh, well, we have to wait for the remote machine to come back, so launch a thread, and then should I redraw this window? Well, it's like, No, nobody has to know. It doesn't matter. Every window can just draw exactly the same way. It just keeps track of whether or not it got back anything that says that it needs to repaint again, right? Furthermore, you don't even have to do something on the same machine to know about that threading. If you want to, you can leave it multi-threaded, because what you can do here is you can just set the repaint frequency very high if you want to, right? You could set the repaint frequency on stale to be 60 frames a second or something. If you do that, because remember, once everything's valid, it'll stop, right? Because if you do that, now you just you hit step and it's gray and then black, right? It'll come in, pretty quickly or whatever. Or you can even drop one frame, assuming that it'll catch up to you in enough time to not have it be black. But you can actually make it so that these things run at, a full 60 hertz or something if you wanted to. And no matter how long it takes for the debug system to go gather all the values, maybe some of them take a long time to gather, you'll still be getting, the user could even organize these by priority. You'll still be going as fast as humanly possible because you can step before it's done filling out some of the later values if they take too long to grab. Maybe they're complicated expressions, I don't know, who knows, right? So that is, I think, everything I had to say about that. Obviously, we can talk a lot more about this architecture later. On the RAD debugger, I actually built this. So I had it all working, and I just didn't have any debug services for it. And so I implemented 100% of this and with a dummy thing that just returned fake values for everything. And I thought it was quite stable. They were using Qt, and basically what I did is that was a real pain in the butt. Qt is such a pile. But I basically just made a little adapter for Qt that would take this interface, which is an immediate mode kind of an interface, right? That just kind of does these loop refresh things, and it would just synchronize a Qt list view to it, and it worked fine. So yeah, I think this is a good way to sort of structure the exterior code. And there's some subtlety involved in getting this sort of stuff right, because you have to really play with it for a little while and think through exactly how to organize those type expression row structs to make all the windows generate properly and to make it nice and consistent for the user to understand what's getting evaluated where. So there is some thinking there. And I would probably even do one more version than the one that I did, because I think there were some other things I could have done better. But that's the basic idea. So I hope that's put enough architectural thoughts in your head too. I don't want to say you have to do it this way or anything like that. That's not my goal. You guys should do it however you want to do it. I just wanted to get all those ideas out there, because as far as I know, they're never going to happen. I don't think anyone's actually using them on the RAD one, because I don't even actually know what they're doing right now. But this stuff I think was all pretty interesting architectural stuff, and I feel like you might be able to use some of it. So there you go. That's everything. And now, before my voice is completely shot, I'm gonna go to bed. Did that make some semblance of sense to everyone? I mean, everyone who's knows what's going on, everyone who was interested in this topic. All right. All right. All right, folks. Yeah, I'm gonna go to bed. Thanks everyone for possibly making this debugging thing happen. Yeah, I'll try to help out as much as I can on that stuff. And I can do another stream if there's questions or things that I can help with. I can put that stuff up there. Panic 00. I think what you described is a good way to write UI in general. Only access a cache from the UI thread instead of trying to do a bunch of work to fetch data. Yeah, it's definitely the case that that system of like update and remember whether I need to update again was kind of really cool when I thought of it as like, okay, yeah, that solves a ton of problems for simplifying systems that would have been very thread-lock dependent. So yeah, I do think it's pretty interesting, and it's very simple, right? It's not like any complicated, crazy thing. It's like, oh yeah, it's just basic, nothing weird. It's just a dirty bit, but once you realize that, hey, this is a dirty rect kind of a situation or whatever, just apply that idea and it kind of works. So yeah, I'm pretty excited about the concept that we may sometime get a debugger in 4Coder so I can literally never boot up Visual Studio ever again for the rest of my life. Dude, that would be so good. Oh my God. Because someday LLVM is going to get there too. Someday. And then that would mean you wouldn't even have to install Visual Studio because you wouldn't even need the compiler. So you would use it live like it never existed. Can you imagine that world? Can you imagine a world where Visual Studio doesn't exist anymore? That's like so beautiful. That's like amazing. Mr. Fourth Dimension, it'll all be in the custom layer too. Oh, that'd be pretty awesome because then you can fuss with it. Yeah. Well, like I said, I'll try to help out wherever I can. It's been really great. I mean, having 4Coder has been amazing. And if now someone's doing work on making a debugger part for 4Coder, that's going to be even more amazing. So yeah, it's pretty great. Pretty great. The day we switch the day we no longer launch Visual Studio on Handmade Hero stream, oh man, that day is going to be the biggest party day of all time. That's going to be like the most party of all party days. Anyway, thanks for tuning in, and I'm going to go send this video off to the folks who asked for it. So take it easy, everyone.